All right, so continuing on from levels 1 through 3, we're just going to go over a quick symmetry example so that way you can do your practice. So number 1 says to construct all the lines of symmetry and locate the center of rotational symmetry. So all the lines of symmetry, remember, mean that I can take this figure and I can fold it in half and one side would match on the other exactly. Now I didn't say that this was a square, but it does say that it's a square down here, so I apologize for that. But if I connect A to C, then this side, ADC, would, if I reflected over that line of symmetry, it would lie right on top of this side as well. So then the other diagonal would be another line of symmetry. Let me make that better. And then also, if I folded this square in half this way, let me make that a little more centered. And if I fold it in half this way, that would also work. So then it said to label or locate the center of rotational symmetry, which is this point here where all those lines of symmetry intersect. And I'm just going to label this point E. It doesn't matter what you label that center, just make sure to give it a name. Now it says to describe all symmetries in this figure. What kinds are there? Well, there's line symmetry, there's rotational symmetry, and there's also identity symmetry, which, remember, identity symmetry just means that you are rotating this 360 degrees and it gets back to the same exact place that it originally was. So how many rotations, including the 360 degree rotational symmetry called the identity symmetry, are there? Well, if there are 4 lines of reflection here, that kind of helps us with this. Now, the number of lines of reflection, which is letter C, we can answer that. The number of lines of reflection might not always be the same number of rotational symmetries. But here with the square, if I rotate point A 90 degrees this way, and point A again 90 degrees this way, and point A 90 degrees this way, and point A 90 degrees again, all 4 of those times that I rotated this figure, your figure would look identical to the original. And again, in this example, the number of lines of symmetry equaled the number of rotations, so 4. And we'll list the rotations in a moment. But on this page here, we talked about how a parallelogram does not have any lines of symmetry, but does have rotational symmetry. So keep that in mind, that the number of lines of symmetry does not always equal the number of rotations. In this case, it did. And since there's 4 rotational symmetries, 360 divided by 4 means that each rotation would be 90 degrees. So it says to list the possible rotations. So here's where we write the set of, and then rotating it about point E 90 degrees would give me 1 rotational symmetry. Rotating it another 90 degrees brings me to a rotation of 180 degrees. Rotating it another 90 degrees brings me to a rotation of 270 degrees. And rotating at 1 more 90 degree angles is 360 degrees, which is the identity rotational symmetry. And so we already answered what are the lines of, or how many lines of reflection. And then it says, now that we have found the symmetries of the square, consider these questions. How many places can vertex A be moved to by some symmetry of the square that you have identified? So basically what this means is that if I rotate point A to point D, your figure would look identical to what it looks like now. If I rotate point A all the way to point C, your figure would still look identical. If I rotate point A all the way to point B, your figure would look identical. And if I rotate point A all the way to itself, your figure would look identical. So how many places can vertex A be moved? It can be moved 4 different places, and your figure would look identical to what it does now. All right, that brings us to the end of levels 1 through 3. We're now going to move on to level 4.